Now in this video, I'm going to be deriving the general expressions for the normal and tangential stresses in Dick cylinders. Now consider a Dick cylinder acted upon by external pressure P0 at the radius B as shown and internal pressure Pi at radius A. So at R is equals to A, I have my radial stress equal to negative Pi. The radial stress is negative of the pressure. So at R is equals to B, I have my radial stress equal to negative P0. So my Lam's equation in terms of radial stress is sigma R is equals to A plus B over R squared. So substituting my first terms here, at R is equals to A, radial stress is equals to negative Pi, I have it as that. Now what I want to do is to remove the A squared from the denominator. So I multiply all parts, all sides by A squared to give me this. And that will be my first equation, 1. Then the next thing is to substitute my next set of values. At R is equals to B, sigma R is equals to negative P0. So I have negative P0 is equals to A plus B over B squared. So multiplying all sides by B squared, I'm left with that. So the next thing is that in my equation 2, I'll make B the subject. So making B the subject, I have my equation as negative P0 minus B squared A. So I'll then substitute in equation 1. So substituting in equation 1, I'll have that. So the next thing will be to make A the subject. So making my A the subject, I'll have negative Pi A squared is equals to that. So I'll first put A to the side. So I have negative. The reason I'm putting a negative is so that I can have B squared minus A squared, since B is greater than A, since B is the outer radius and A is the smaller radius. So the next thing is to put this term to the other side. So I have it as that. So the next thing will be now to divide by negative into brackets B squared minus A squared. This will leave me with AS. This will leave me with AS as Pi A squared minus P0 B squared over B squared minus A squared. So I put this as my equation 3. So now the next thing will be to substitute 3 into 1. So my equation 1 is this. So substituting my 3 into 1, I'll have it as. So I'll then make B the subject of this equation. So making B the subject, I have this. So my LCM is B squared minus A squared. Solving this, I'll have that minus this. I'll remove my brackets in this next term. So I'll negative Pi A 4 plus P0 B squared A squared. So removing my brackets in my first term, I have. So these two will cancel and I'm left with my BS P0 minus P A squared B squared or B squared minus A squared. So now I expect my internal pressure to be greater than my external pressure. So I'll have a negative to the side so that I can have P internal minus P external A squared B squared over B squared minus A squared. That's my equation 4. Now, since I have my A term and B term, I then substitute in my Lam's equation, which are sigma R is equals to A plus B over R squared. My tangential stress is equals to A minus B squared over R squared. So substituting my A and B, I'll have my two terms as sigma R is equals to and sigma theta is equals to these two are the general expressions for the normal stresses, sigma R and by tangential stress. So from this equation, my radial stress has a negative sign showing that it is compressive, whereas my tangential stress has a positive sign showing that it is tensile.